The overall goal of this procedure is to synthesize immunotargeted Magneto-Plasmonic Nanoclusters with a strong magnetic moment and a strong near-infrared absorbance. This is accomplished by first synthesizing iron oxide core nanoparticles. The second step is to deposit a gold shell onto iron oxide core nanoparticles. Next, the nanoclusters are formed by an oil and water microemulsion approach. The final step is to conjugate monoclonal antibodies to the nanoclusters. Ultimately, dark field imaging is used to show the molecular specificity of the immunotargeted Magneto-Plasmonic nanoclusters.
Our approach provides the combination of a simple synthesis, nanoparticles with strong magnetic moment without sacrificing their superparamagnetic properties, and strong visible near-infrared absorbance that addresses all major limitations of previous methods. And the procedure will be demonstrated by graduate student Frank Wu, who has developed the procedure in my laboratory.
To make the nanoparticles, first set up the labware. In a fume hood, connect a round bottom flask to a condenser and immerse it in a silicone oil bath on a hot plate. Monitor the bath with a thermometer that can read above 260 degrees Celsius. Wearing protective garments, start combining reagents in a metal flask as the reaction temperatures are very high for Pyrex. To make the magnetic nanoparticle suspension, combine iron acetylactinate, oleic acid, olealamine, 1,2-hexadecane diol, and phenyl ether. Stir the mixture vigorously and heat it to 250 to 260 degrees Celsius.